Welcome to today's Explainer. Get ready, because we're about to fundamentally change how you look at data processing. We're going to systematically deconstruct exactly how you can transform a regular, seemingly static spreadsheet into a fully autonomous, low-code AI pipeline. We're talking about taking everyday tools and literally supercharging them into an enterprise-grade enrichment engine. Let's get right into it. Here's our blueprint for this build. We'll kick things off with the cognitive spreadsheet era, then dive into webhooks and state management, prompting for structured JSON, setting up rate limits and guardrails, and finally, we'll put it all together into a solid 7-step AI pipeline.
So starting right off with part 1, the cognitive spreadsheet era.
To really grasp the power of the setup we're building, we actually need to rewire our brains a bit. We have to stop viewing Google Sheets as just some basic office tool you use for budgeting or tracking attendance. Instead, think of it as a cloud-native, tabular database and user interface, right? By looking at it through that specific lens, we can wire that familiar grid directly into the reasoning engine of large language models, like OpenAI's GPT-4o or Claude 3.5 Sonnet. Suddenly, those static rows are totally alive. They're capable of doing batch content generation, sentiment analysis, dynamic data enrichment, the whole shebang.
All right, moving on to part 2, webhooks and state management.
To make this system truly autonomous, we have to build its nervous system. Now, there are basically 2 different ways to detect changes in our data. On the one hand, we have polling triggers. Think of polling like a kid in the backseat repeatedly asking, "Are we there yet? Are we there yet?" It just periodically checks the sheet, maybe every 15 minutes, to see if a new row popped up. But on the other hand, we have instant webhooks using Google Apps Script. These act immediately. The exact second a cell updates or a form is submitted, it pushes an instant HTTP post payload directly to our low-code automation tools like Make.com or N8N. It's 100% event-driven, which is exactly what we want.
But here's the catch with instant triggers. To prevent infinite loops and crazy race conditions, you absolutely must implement row-level state management. Just look at the tracking column here, the status column. A row starts out as pending, gets locked into a processing state while the AI does its heavy lifting, and then finally updates to either complete or failed. Without this explicit status lock, your automation might try to process the same row a dozen times all at once, eating up all your API credits and causing absolute chaos. We definitely want to avoid that.
That brings us to part 3, prompting for structured JSON.
Okay, so our data is moving safely, but how do we actually talk to the brain of the operation without getting messy, unpredictable outputs? Well, we isolate our system prompts so they behave strictly as data processors. We do not want conversational fluff, no chatty text wrappers from the AI. We pull this off using dynamic variable injection, by mapping spreadsheet cell values directly into the prompt using placeholders, like those double curly braces around column B. The AI only sees the exact piece of raw text it needs to analyze, all completely programmatically.
And to guarantee the AI plays by our rules, we use structured outputs. The OpenAI API documentation actually explicitly states that by using their JSON schema features, you guarantee reliable type safety. This is a real game changer. You no longer have to write those strongly worded prompts literally begging the AI to format its output correctly, and you don't waste API calls retrying failed attempts. It absolutely forces the model into the exact data structure your spreadsheet needs.
So what are our rules of engagement here? First, we define strict system boundaries. Then, we enforce JSON mode response formats, specifically telling it to output a JSON object. By locking the AI engine into these rigid enforcers, we guarantee that the return data, whether it's extracting a sentiment or generating a summary, maps cleanly, safely, and perfectly right back into the distinct columns of our database. No more messy data.
Next up, part 4, rate limits and guardrails.
You know, even the most elegantly designed systems are gonna crash if they try to consume way too much data too fast. We have to protect our system from hitting API quota limits, like requests per minute or tokens per minute. We mitigate this through deliberate iterator delays and exponential backoff. For ultimate efficiency, we use array aggregators to group multiple AI responses together. That lets us execute a single bulk write to the spreadsheet instead of making 100 individual API calls. And honestly, this is absolutely crucial. We set up fallback routes. If a prompt fails or times out, our error handler flags that specific row as failed, rather than shutting down the entire pipeline. It's just smart design.
All right, the moment we've been waiting for. Part 5, the 7-step AI pipeline. Let's bring this whole thing together. These 7 actionable steps are your exact Make.com architecture blueprint for building this continuous data enrichment engine. Step 1, prep the sheet with your essential status and timestamp columns. Step 2, set up a watch rows trigger, filtering only for pending and capping it, maybe at 10 rows, to respect rate limits. Step 3 is vital. Immediately update that row's status to processing so you lock it. Step 4, hit the OpenAI module to process the text and return a JSON object. Step 5, parse that JSON payload so the automation actually understands the individual data points. Step 6, map those extracted insights right back into the correct columns and update the status to complete. And finally, Step 7, run a test and turn the whole automation on. Boom!
Tracking just a single row through this timeline is honestly a thing of beauty. You can literally visualize the life cycle here. At 0 seconds, a static piece of text gets detected. By 1 second, it's locked into processing. At 3 seconds, the large language model is cognitively analyzing it. At 4 seconds, the JSON is securely parsed. And by 5 seconds, your spreadsheet is completely updated with rich AI-generated data and a finalized timestamp. 5 seconds. To put that into perspective, that's all it takes to complete a task that would easily take a human hours of mind-numbing manual entry. Now that you hold the foundational blueprint to turn any tabular data into a scalable, autonomous cognitive engine, the tools are completely in your hands. You know exactly how to manage state, enforce strict JSON structures, and build resilient enterprise-grade architectures. So I'm going to leave you with this final thought to chew on. With a powerful pipeline like this at your disposal, what will your spreadsheets autonomously process next?